Okay, here we're going to look at multiplying indices. What we've got here is we've got the rule a to the m times a to the n equals a to the m plus n. What does this mean? This means that if we've got a term multiplied by the same term with different powers, we can simply just write it as that term and add the powers together. For example, if we had 5 cubed and we were multiplying it by 5 squared, first thing we can spot is they're both 5s. Both the bases are 5. So I can write that as 5. And then I can simply just add the powers. 3 plus 2. Which will give me 5 to the power 5. We did another example. 7 to the power 10 times 7 to the power 6. They are both 7. So I can combine them. And we're multiplying, so that means that we add 10 plus 6 equals 7 to the power 16. In a question such as this one, what we have to remember is that we can only add the powers together if the bases are the same, if the numbers or the terms are the same. So I can only do this 5 with this 5, this 7 with this 7. So looking at the 5s, I can write that as 5, and see this 5 here. If there is no power attached to it, it's just to the power 1, because anything to the power 1 is just itself. So looking at the 5s, I can combine 5 cubed and 5 to the power 1, and they're multiplying. So that will be 3 plus 1. And that's multiplying by the 7s. I've got 7 squared times 7 to the power 9. I can do 2 plus 9. And just tidying that up, I'm going to have 5 to the power 4 times 7 to the power 11. What using this property of indices allows us to do is allows us to write really long, complex calculations in a more concise fashion. Okay, here we've got 3 examples. We'll just go through them quickly. So x cubed times x squared, the base is both x. So I can simply just add the powers. 3 plus 2 is going to give me x to the power 5. This example here, y to the power 9 times y to the power 6. Both are y's, so I can add the terms together since they're multiplying. I'm going to get y to the power 15. And at the bottom we get z to the power minus 1 times z cubed. So even though there's a negative, I can still apply my rule. Minus 1 plus 3 is 2, so it would be z squared. I would say that this is a more examinable question because it's got negatives involved. You need to be able to work confidently with negatives when we're doing these sort of calculations. Okay, here we would ask to multiply x to the power a third times x to the power a half. So, despite the fact that we've got fractions, we just apply the rule as normal because they're both x and we've got multiplying. So what that's going to turn into is going to be x to a third plus a half. So we are now going to need to do this calculation. Generally, I would advise you to do the calculation at the side. Don't just try and cram it into a really small space. Give yourself room at the side. You will have side space in your jotter or in the exam at the side of the paper. When we're adding fractions, we need to make sure that the numbers at the bottom are the same. So the lowest thing that 3 and 2 both go into is 6. To get from 3 to 6, I have to times by 2, so I'm going to times the top by 2 to get 2. To get from 2 to 6, I need to times by 3, so that's what I'm going to do to the top. 1 times 3 is 3. I can then write that as 5 over 6. And now that I've added those fractions together, I can write it as x to the power 5 over 6. Okay, last example for multiplying. We have got negatives and fractions. We still use the same rule because this is the same as this, and we've got multiplying. So, we can add the powers together. Plus 3 over 2. And once again, we don't have space for it, so we're going to do it at the side. So, minus 4 Remember, you can write a fraction as minus 4 over 1 plus 3 over 2. We need the same denominator, so the lowest thing that 1 and 2 both go into is 2. To get from 1 to 2, I have to times by 2, so I'm going to multiply the top by 2. And then I can tidy up minus 5 over 2. And then I can just write this as y to the power minus 5 over 2. You need to be able to work confidently with fractions and negatives, particularly with indices, if you want to have a chance of doing quite well with the more complex questions in the exam. So I'm just going to include one final example because we've not really covered one of this type. Okay, so we have got two terms multiplying, the terms are the same. We've both got powers and we're multiplying, so that means I can add them. So I'm going to have 5, then I'm going to have 6 plus minus 2. Okay, and this is when we need to kind of recall back to our integer facts. When we are adding on a negative, that means we need to take away. So 6 plus minus 2 is the same as 6 minus 2, and 6 minus 2 is 4. If you're confident with the examples really covered in this video and you can do them without any issues, you should be quite confident with most of the topics with indices. Thank you.